Howdy and good day, Algebra. Before you go on to CO46, we are finishing up PO45. There's one thing on this page that we didn't get to talk about, and then I am going to show you a third. You do that again, you're out of this room. I am going to show you a third method that you can use to multiply not only binomials, but nomials of any kind. Yes? Yes. So for starters here, we've got this 5x plus 1 squared. The location of that exponent is important. Okay? The fact that it's outside of the parentheses means that what's being squared is everything inside of the parentheses. So 5x plus 1 times itself. How you write that, 5x plus 1 times 5x plus 1, oh, well, now it just becomes any other old man foil or crab claw situation, right? So if you have an exponent outside of parentheses, you're squaring a binomial. It's not just good enough to square the 5x and square the 1. You need to write it out as 5x plus 1 times 5x plus 1 and square both binomials using one of the processes that we talked about the other day. Yeah? For what? Sure. Okay, so hopefully that clarifies that and then helps with that second one too. But the new method I'm going to show you today is actually going to be, we're going to use this one here, the 4x plus 9 and the 7x plus 1. You have background in this overarching concept from science. Do you remember when you did gene studies and did the Punnett squares or whatever? Yeah, it kind of goes back to that. If we are multiplying a binomial times a binomial, with the intention of distributing that 4x into both terms in the other set and distributing the 9 into both terms in the other set. We can use old man foil. We can use crab claw. We can also use what's called the box method. And so we're going to draw more of a rectangle than a square because I want room to write horizontally here. But I'm going to make a box just like that. So a Punnett rectangle maybe. And across the top, it doesn't matter which binomial goes where, but across the top, I'm going to write one of them, 4x and 9. And down the side, I'm going to write the other one, 7x and 1. And can you see where I'm going with this? Can you predict what is going to fill in our box? Elise? The products of each set of terms here. So the first one, 7x times 4x, gives us 28x squared. You can see why I want that space to write horizontally, so I'm not trying to squish these in here. Okay, 7x times 9, 63x. 4x times 1 is 4x, and 1 times 9 is 9. So same result, right? We get an x squared term. We get two x terms that we can combine. 63x and 4x are like terms here. And then we have a constant. Just a different way to do it. Our final answer, 28x squared plus 67x when we combine our 63x and our 4x plus 9. Nifty, isn't it? Yeah. And the nice thing about the box method is not only does it work for what we did in PO45, but it's going to be the go-to method for CO46. Because in CO46, we graduate from a binomial times a binomial to a polynomial times a polynomial, which can include any combination of nomials. A 2 by 3, a 3 by 3, a 2 by 4. And the reason why we like this box method in this case is that, you know, if we're going to distribute, just look at this one here. If we're going to distribute, which is essentially what we're doing here, that 3x cubed to every term in the other set, and we're also distributing the 4x squared into every term in the other set. And we're also distributing the negative 5x in every term in the other. I mean, that's a lot of lines, right? Looks pretty cool. It's like a triple crab claw, but it's easy to lose track of things. So the box method is a much more organized and preferred way. Let's start with this one up top though. 7x minus 4 times 2x squared plus 4x plus 1. What dimension box am I going to need to make for this, Brent? A 2 by 3. Does it matter whether it goes 3 vertical or 3 horizontal? No. I'm going to make mine go 3 horizontal though, just so I have a little more space. No reason to try and, squish everything in a small space. Make your box nice and big. My trinomial goes across the top. 2x squared, 4x, and 1. My binomial goes on the side, 7x. And don't forget that negative 4. That sign belongs to the 4. It's got to come along with it. Okay? And just like in the example we just did, we're going to fill in all of these boxes with the products of the terms. So 7x times 2x squared is 14x cubed. 7x times 4x is 28x squared. And 7x times 1 is 7x. The bottom row, 2x squared times negative 4 is negative 8x squared. 4x times negative 4 is negative 16x. And 1 times negative 4 is negative 4. A lot cleaner than drawing all the lines, right? And again, like the theme of this unit seems to be, it's not the math that's difficult, it's the remembering the details. If you didn't bring this negative sign down with the 4, as you should, how does that change things? Pretty drastically, right? If you put positive 4 here instead of negative 4, then all these terms in your second row will be positive, which not only makes them wrong, but then when you go and combine like terms, if that's a positive 16 and a 7x, that's going to be a different sum than what it should be, which is, I'm still erasing here, then negative 16 and positive 7x. So make sure that you are keeping track of negative signs and exponents and all that stuff. Putting our final answer together here, standard form, I only have one x cubed term. So that's going to come first, 14x cubed. I've got 2x squared terms. And now that I'm combining like terms, I'm adding and subtracting these, which means that my answer is still going to have an x squared, right? It's a different operation than multiplying. So it's going to be 20x squared. The exponent changes when we multiply them, but not when we add or subtract them, which is what I'm doing now. My x terms, negative 16 and positive 7, is a negative 9x. And then negative 4 is my only constant. That goes at the end. And there's my answer. Questions on that process at all? Yeah. Now that you've seen all three methods, where are my FOIL fans? Ooh, nobody. Good thing Old Man FOIL isn't here to hear that. Where's my crab claw crew? Few of you?
For these or for all?
For binomials. Going back to binomials. For binomials, who's the where are my FOIL fans? Any FOIL fans for binomials? Brent, you're back in the
Oh no.
I won't tell them, that's okay. Crab claw clue for FOIL fans. How about for multiplying binomials, who thinks the box rocks? Few of you. All right. So yeah, so three different methods for binomials specifically, which is the majority of what we're going to be multiplying together going forward. But the box definitely works for these here. So that's all I've got to really teach you, because from here it's just setting it up. So we'll go over one other one together, any from the page that you want to. This page or the next page. Is there one that looks particularly worthy of doing today in class? From either page. Soybe.
On the second page, it's 6x minus 5.
So if the first one?
Yeah.
So this one, we've got a 2x4, a binomial times a polynomial. So I'm going to make a 2x4 box. Again, no point in trying to squish things together. Give yourself some space to write here. Okay. My polynomial is going across the top, 11x to the fourth, 2x cubed, negative 4x, positive 3. My binomial down the side, 6x, negative 5. And again, what fills in the box is just the products of each of the terms. So 11x to the fourth times 6x, 66x to the fifth. 2x cubed times 6x is 12x to the fourth. Negative 4x times 6x is negative 24x squared. And 3 times 6x is 18x. Bottom row, 11x to the fourth times negative 5 is negative 55x to the fourth. Then negative 10x cubed, positive 20x, negative 4 times negative 5, positive 20. And then negative 15 to finish it out. And you'll notice when I start to write my final answer here, standard form, I'm going to start way over here on the left side of my page because this answer is going to be long. Got a lot of terms here. 66x to the fifth is my only power of 5. But I do have 2x to the fourths I can combine. Negative 55 and positive 12 is a negative 43x to the fourth. I do only have one x cubed term, so minus 10x cubed. Only one x squared term, negative 24x squared. My two x terms combine to be positive 38x. And then my constant of negative 15. Now, is that an algebra answer or what? Like that just screams, welcome to algebra class.
Welcome to algebra class.
Exactly. Last year I taught grades 6 through 8. And the way it worked out, my 8th grade algebra class was right after my 6th grade class. And I would like to leave the work from algebra up on the board just so that the 6th graders would come in and just their jaws would drop. What is that? Okay. And if you paged through the unit before we actually started, you probably thought the same thing. What is this? What am I doing here? Right? But hopefully you are seeing that it's a lot easier than it looks. Right? Once you get the rules for how to multiply exponent terms down and combine like terms, the addition and subtraction, it's the details that really are what to focus on here. But yeah, if I could spell algebra, that's how I'd spell it.
A-J-L-P-H-A-R-A.
Close enough. I'm proud of you. All right. Any other questions on CO46? Okay. Because it's a lot easier to make you hate me than it is to make you like me, the homework for the weekend is the rest of PO45 and all of CO46. You do have 4 days to do it. You've got, 5 days. You have tonight, you have Thursday, you have Friday, you have Saturday, and you have Sunday. Retake day. Sorry, I should have mentioned that earlier. So you have plenty of time to get it done. But all of PO45 and all of CO46 due on Monday. You do not need to show your work for PO45 because we're at the point now to where if you can do the binomials mentally, do it. But you need to see. I need to see the work for CO46. I need to see the box. Okay? Because if you could do these mentally, then we need to have a conversation. Because teach me how. All right? Okay, with gusto, that's iMath.
Don't forget to like and